We'll give it a second for people to catch up. Welcome, everybody. This is an additional seminar in our National Security Decision-Making Game seminar plan for Gen Con. We want to welcome you to our session. And today we have Elizabeth with us, who's one of our new team members. And there's a little background slide so you can see her. And she's going to talk to us about robotics and extending our reach. And you can see that we're talking to you from the NSDM Robots Scrapyard, because that's our backfill now, because we're getting more creative as we move along. And welcome again. So I'm going to pass things off to Elizabeth to talk about herself just a little bit, and then start into the presentation.
All right, thank you, Merle. So today I want to talk about robotic spaceflight. So a little bit about, I put in the NSDM slide first, and I am very happy to have joined the NSDM team for Gen Con, to be invited to do so after talking to them after a seminar last year at Gen Con on the solar system. NSDM is a nonprofit educational group providing, basically educating on historical decision-making and contemporary decision-making through games and seminars, and understanding how world decisions are made. A lot of people from the team have experience from military, government, academic, and business settings, as well as a lot of hobby experience. And we appear at hobby conventions, academic, and government venues. So far, I've only done the hobby conventions, but my background is a bit academic. So the standard disclaimers, all based on public information. All use of pictures follow fair use and Creative Commons. And you'll actually see, I'll talk a little bit about image use, but you'll see that I do have photo credits throughout. And in fact, part of the discussion will be how you can get access to this data and do cool things with it. Opinions, errors, and omissions are mine, and no content should be considered to represent the opinions or policies of any of my employers at any time. I should also add that nothing should be construed as expressing the opinion of institutions and organizations that I am volunteering for. So, a little bit about me. I'm a maker professional. I am staff at the University of Chicago, where I run a makerspace. And I also volunteer as a NASA JPL Solar System Ambassador. So I'm one of over 1,000 faces of the Jet Propulsion Lab who are presenting robotic spaceflight to our communities. I also volunteer at the Adler Planetarium in Chicago. And you might have noticed in the fact that I'm coming to you for Gen Con that I am in fact a geek. So I wanted to talk about robotic spaceflight. And by robotic spaceflight, I mean what can also be called uncrewed. So this is space as done by robots and not as done by humans. All of it is exciting. Robots generally don't come back to Earth and don't get parades. So this is something that I feel worth talking about. And I am excited to see, since I really got interested in this in 2012, to see more coverage in geeky and tech media of missions like the Curiosity rover or the Perseverance rover, which we'll talk about, New Horizons, etc. But I titled this Extending Our Reach because that is what these robotic space missions do for humans. I put a quote from the amazing Emily Lakdawalla, a planetary science author and science communicator. Said, "We send robots because we can't yet send humans. For now, those robots are us. They are the thin wedge tip of humanity's presence across the solar system. Only 12 humans have ever walked on another world, but through the footpads of landers, the wheels of robots, the bottoms of probes, all of us humans have touched other worlds, the hands and brains of scientists and engineers on those missions." And it's also worth pointing out with this, and I believe that is something that Emily Lakdawalla has talked about a lot herself, that all of these space missions, and in fact human missions as well, take thousands of people to accomplish. So it's maybe a little clearer when we're talking about teams of people working with robots, but just remember it's scientists, it's engineers, and it's lots of other people who are contributing to this work. A little bit of a discussion. My intent with this talk is to introduce a few of the many interesting robotic space missions and give you an idea of where to look for more information. This is not going to be comprehensive in any way of the missions that are active right now. It's certainly not going to be comprehensive of the over 50-year history of robotic space missions, starting with Mariner 2 in 1962. There we go. It is not going to be comprehensive of all of the global space agencies. So my focus is definitely going to be on NASA in particular and the Jet Propulsion Lab, which is part of NASA, as well as other NASA contractors. So it's going to be US-centric. But there are many that is not to insult the amazing other missions that are happening from space agencies around the world. And I'll mention a few of them as we go through here. And in fact, some of the missions that I'm going to highlight do have instruments and collaboration from international partners. This is an international endeavor. So start with Perseverance, which I'm very happy to say launched 2 days ago. This is the Mars 2020 rover. You can see her right there in the clean room. It looks like there's some testing of her rocker bogies. So you can see there's a suspension with these 6 wheels, and they're sort of independently driven. So the rover can maintain her balance while going over rough terrain. You can see there's sort of a hinge for the front 2 wheels on each side. This is, and you can also see towards the front, point over there, there is a robotic arm. So this is going to look similar when we look at the Curiosity rover. This is the newest and most advanced Mars rover that NASA has made. It is being sent to Mars to look for signs of past life and to cache samples. This is part of a Mars sample return mission, because as amazing things as we can do with robots, we'll talk about some of their instruments, there are still some things that are going to be a lot faster if we can get them back into a lab on Earth where a scientist can interact with them more directly. So this is the first part of a planned mission architecture to collect samples, cache them somewhere, with the potential of another mission going to collect them, blast them into orbit, where another mission is going to collect them and return them to Earth. So it's a very exciting mission architecture. We can also see the rover looks like she sort of has a head. That's called a mast, and that is, it has a mast cam on it. It's called Mast Cam Z. So it's a camera. It also has a laser. So this is similar to the Curiosity rover that has a laser to zap rocks and analyze the light coming off of them as a part of a way to characterize the rocks. That's part of what that Perseverance will do. Perseverance also carries a microphone. This is something that many people wanted to go to Mars so that we can hear what the wind sounds like. And also, hearing the sounds of the rocks being zapped will give us information about the rocks. And hearing sounds of equipment and motors, just think, from working with machines, when you work with a machine, you understand what's happening by hearing what the machine is doing. So this will give us some of that information on another world. And Perseverance carries a little helicopter. This is going to be the first powered flight on another world. The helicopter is named Ingenuity, and it has these rotors you can see up top, and they spin 2 different ways. They spin opposite of each other. It is very challenging, and interacting with Mars's atmosphere is always very challenging because there's some, but it's incredibly thin, and it's majority carbon dioxide. But so flying a helicopter on another world is going to be a great challenge. And this is, Ingenuity is planned as a technology demonstrator. So she does not carry science instruments. She's going to be active maybe for a few weeks. And Mars 2020 can be, I believe the prime mission is a Mars year, which is about 2 Earth years, similar to what Curiosity has. But a lot of these missions you'll see actually last well past their prime mission. So it'll be useful, but you can think of this kind of like Mars Pathfinder and Sojourner. So that was a mission that landed in 1996, had a lander with a bunch of science instruments, and also a little rover that was mostly a technology demonstrator of, can we have a little rover on Mars? So moving on to something a lot different. This is the Parker Solar Probe. So this is the first and only NASA robotic spacecraft that is named after a living person. The living person is Dr. Eugene Parker, who is a professor emeritus at University of Chicago. And he was the first person to theorize the solar wind. So appropriately enough, this is a mission that is going to get the closest to the sun of any human-made object and report back. And of course, it's very important to understand space weather to avoid solar storms, things that can disrupt communications, power grid, and also other spacecraft. So you can see from this is an artist rendering, and you can see some solar panels that are sort of folded back towards the right bottom of the image. And the probe has this round/rectangular heat shield that is being pointed at the sun. So basically the instruments that are behind that heat shield will be kept at room temperature. And the heat shield is going to get incredibly hot. One of the other things that the Parker Solar Probe is exploring is the corona of the sun that extends well past the surface is very, very hot compared to the surface. That's been kind of a mystery to understand why that is. That's one of the things that it is exploring. Some of the data so far that has come back had to do with looking at ripples and reversals in the sun's magnetic field and how that relates to flares and to sunspots. Also, there is a camera called WISPR. It's a wide imaging something. I don't remember the rest of the acronym. Anyway, this is a visible light camera. And in addition to observing the sun and specifically the corona of the sun, this also caught comet NEOWISE when very close to the comet's perihelion. So when it was closest to the sun. And in fact, the sun is out of the frame, it's over to the left. And you can see there's sort of an ion tail to the top and then the dust tail below this. So with the Parker Solar Probe is currently doing a flyby of Venus, which actually is helping it slow down so it can start orbiting even closer to the sun. And the closest it's going to get, I believe, is about 4.5 solar radii, which is actually considered in the corona because the corona is just that big. So I talked a little bit about Mars Curiosity, and here is a little bit more about her. I have to admit I'm a little biased. When Curiosity landed on Mars in 2012, that's part of what rekindled my interest in robotic spaceflight and science and tech communication. And it was super exciting. So this is I'll show a comparative picture in a bit. This is a comparatively large Mars rover. It's about the size of a car. She's about the size of a car. At the time, the heaviest and most capable Mars rover sent there, and in fact, the heaviest and most capable currently on the surface. She also has the capability to take selfies. So you don't see the robot arm in this photo. That is because the robot arm has been extended. So like a person taking a selfie with their phone, she's holding out her robot arm and taking pictures from all angles. And then those pictures, this is about 58 frames that are put together in this mosaic, and it distorts the perspective around it to focus in on the area in front of Curiosity where she has been drilling. So you can see there's sort of these, the surface is kind of yellowish, and then there's these piles of grayish dust, and that is where Curiosity has been using the drill on her robot arm. So Mars Science Laboratory, the goal of Curiosity is to find out if Mars was ever habitable. Not if there ever was life there, but could there have been? So Curiosity's instruments are like taking an entire analytical chemistry laboratory that would fit in a room, putting it in a box the size of a microwave, hardening it against radiation, and shooting it to Mars. Not exaggerating. So the drill drills into the rock, takes samples, and ingests it into the sample analysis at Mars instrument. And there's also, I mentioned the ChemCam. So that's the laser on the mast of Curiosity. So kind of distance lasering rocks and looking at their spectra. And then that can also be compared looking, I think it's generally like look at the rocks, see if they're interesting, and then deciding to drill because there is a limited number of sample slots within Curiosity, I believe, and a limited amount of reagents inside. So here I mentioned multiple generations. So with Humans for Scale in the Mars Yard at JPL, so at the Jet Propulsion Lab, this is where they practice driving Mars robots. You can see the smallest one here is Sojourner. This is a little technology demonstrator with 2 science instruments. And then over here is the Mars exploration rovers. These are Spirit and Opportunity. Both of them had a 90 Martian day or SOL prime mission. And afterwards, Spirit lasted for about 6 Earth years, and Opportunity lasted for about 14 before we lost contact with her due to a planet-wide dust storm that probably made it, a number of things. Basically, she lost power and was not able to communicate or potentially like wake up effectively from a low power state. So because Opportunity is solar paneled or solar powered, and you get huge dust storms on Mars. Sometimes they can engulf the entire planet. So looking at the very successful mission of Spirit and Opportunity, and also recognizing kind of some of the dangers and where it could be improved, Curiosity and also Mars 2020 are nuclear powered. So if you saw my Partners in My Chernobyl talk last night, you know I'm going to be talking about a little bit about nuclear things. So back here, this is actually on this model, there is not a model of the radioisotope thermal generator. This is the big thing sort of with fins on the back of the Curiosity rover. There's powered by plutonium-238, which generates a lot of heat due to radioactive decay. And then basically it's something like a thermocouple that uses that heat. With this, it could last at least 14 years and continue powering the rover for at least 14 years. Now, this is radioisotope thermal generators are something that are commonly used on probes that go past the asteroid belt. And anything that goes far enough where there really is not going to be a lot of solar power. So for example, Voyager 1 and 2, Pioneer, all of 10 and 11, all of those used radioisotope thermal generators, and often they'd be put on sort of a boom away from the rest of the instruments. Also magnetometers generally also go somewhere away from the rest of the image of the instruments, so they're not interfered with by the electronics. And another, honestly, Curiosity selfies are just good. But this is showing, so Curiosity is currently in Gale Crater, mentioning looking to find out if it could have been, if Mars could have ever been habitable. And what she found out is yes, definitely. So with Gale Crater was shown to have had water at one point and also to have had flowing water. So one of her first discoveries was conglomerate rocks, which indicated a flowing stream that'd be about knee-high on me. And since then, there's also evidence of like multiple lakes in this crater that were there and then were slowly drying up. This would be very, very early in Mars's history, generally in the period of like 3.5 billion years ago or earlier. You can also see the middle of Gale Crater. There's this hill of sediments. That's nicknamed Mount Sharp. So that this was very early in the mission, and since then, Curiosity has driven towards Mount Sharp. You can also see one of the reasons that the rover takes selfies, not just because they're interesting and popular for outreach, but also to see how much dust is accumulating, to see how the instruments are doing, and check the wear on the tires. One of the things that they learned from this mission is that there's actually a lot of wear on Curiosity's tires, and they are designed to roll even with holes in them, but the wheels on Perseverance have been completely redesigned based on what we learned from Curiosity. I mentioned the radioisotope thermal generator. It's here towards the back. So, speaking of missions that are going out past the asteroid belt, we have Juno, here seen in an artist's representation. Now, after talking all of this about how we don't send things with solar panels out past the asteroid belt, hey, look, we have a mission at Jupiter with solar panels. One of the things you'll notice is that there are 3 banks of solar panels on Juno. Some other missions, such as Dawn, that went to the Dwarf Planet Ceres and the asteroid Vesta, had like 2 large solar panels like wings. Juno has 3. They're quite large, and that is to maximize the amount of power that is coming from the sun because she is so far away. So this, she arrived at Jupiter in 2016. And she's on a polar orbit. So that is orbiting over the poles and carefully maximized to avoid too much exposure to the radiation environment at Jupiter, which is seriously intense. Now, the initial plan had been to do some 53-day orbits to, once a spacecraft arrives at its destination, it's very common to go through and test the instruments, look at the data that you're getting from them, and then, begin with science operations. So there was an issue with one of the propulsion systems, though. So the team decided not to tighten up the orbit. She was supposed to go into a 14-day science orbit, and that has not been the case. So instead, perijobes happen every 53 days. And I believe they're just finished with perijobe 28. That is the 28th close flyby of Jupiter. I mentioned I was going to talk some about images, about instruments. So my other bias with this is it's very visual. And very much talking about the cameras on these missions, but it's worth mentioning they come with lots of images. First of all, images are data. Even if the instruments that are cameras often have filters to look in multiple wavelengths of light, not just visible. So you can learn a lot from the ultraviolet, from the infrared, and sometimes combine those into photos with the visible light. Also, I mentioned magnetometers. The magnetic field of a planet or a moon, you can look at the different spectra of the planet. The Cassini mission at Saturn, when it was looking at Titan, also had synthetic aperture radar, so that is seeing through the thick methane clouds on Titan, Saturn's moon, and actually giving us glimpses of the surface of Titan, which is really exciting.
So Elizabeth, we have a question.
Please.
These probes and robots often outlive their planned mission durations by huge margins. Can you talk about that a bit?
Absolutely. Yes, that is completely accurate for most of the missions I'm talking about, in fact. And part of that is honestly a tribute to the engineering that goes into the missions to plan for a lot of different contingencies and hopefully to say, like, this is supposed to last 90 sols. We know it'll last 90 sols, and then hopefully maybe later, oh my gosh, so much later. So it's just really amazing planning and engineering, and very, very careful and thought through with lots of testing, and in some cases, redundancy of systems as well. So it's exciting. It can, as missions continue, they do need to continue to have resources. So it is kind of an interesting question in terms of funding and staffing and all of those sorts of things. But yes, it's exciting when they can have multiple extended missions. And Juno, partially because of the orbits and partially she did get approved for an extended mission. Yeah, great question. So what you're seeing here, this is one of the poles of Jupiter. And the interesting thing this is from some of the earliest images from Juno. And what we're seeing here are these sort of, it's not really the organized bands you see towards the equator, it's all these little bits and swirls of storms. This is very different from the poles of Saturn, where there's at least one hexagon at one pole and potentially at both. So it's a totally different cloud and weather pattern with our gas giants. This is the other pole. I believe it goes north to south on this. And there's also one of the things that scientists have been looking at with Juno recently is how much water is actually in Jupiter, because that gives us information about Jupiter's formation. The theory is that it formed, was the first planet to form after the sun had formed from the protoplanetary disk. So the cool thing about Juno is the camera on here is actually explicitly a outreach instrument. So the mission did not actually require a camera, but one was added. And with it, they're doing really amazing things with outreach. When I talk about data, I'll actually show that website. They're definitely encouraging people to process and also make art with the images. And if you're an amateur astronomer, you can upload telescope photos and point out areas that you would like JunoCam to take pictures of. And in fact, this is a little storm. It's the middle one here, nicknamed Clyde Spot, named for amateur astronomer Clyde Foster. And also with this particular image, it was processed by Kevin M. Gill, who's another amateur image processor. Excuse me. So there's been a community of people looking at these images, doing things with these images for a very long time, but it's exciting to see this being acknowledged by JPM. So to communicate with all of these missions, there's the Deep Space Network. This is a network of antennae. They're spaced approximately 120 degrees around the globe. There's one, this is Goldstone, California. There's one in Madrid, and there's one in Canberra, Australia. Huge networks of radio antennas. And this was actually the part where I would like to share another screen. How does this work? Might need some help here. Let's see.
You're doing good. Just share the new screen, and I'll bring it into the broadcast.
Cool, got it. All right, so This is a public website. It's called the Deep Space Network now. And this is from real data. It shows which antennae are talking to which spacecraft. So pretty much whenever you open this website, you will find that somewhere someone is talking to one of humanity's robotic space explorers. So right now, actually Goldstone, they're talking to Voyager 1. You can see information such as the round trip light time. This is far enough away that the round trip light time is 1.73 days. And for contrast, when at Mars, round trip light time is about 14 minutes.
So we have another question.
Please.
So has there been any static regarding the power systems for the Mars rover? There have been protests or comments in the past?
Yeah, that was specifically, I know there was specifically related to the Cassini spacecraft and the potential that it was doing a flyby of the Earth. So any of these systems with the plutonium pellets, they take into account potential accidents in terms of launch and in terms of flyby of the Earth. I had not heard of any static or concerns related to the 2 plutonium-powered Mars rovers. Interesting question. Cool. So yeah, what else? I mentioned the Parker Solar Probe. So right now in Australia, they're talking to the Parker Solar Probe. You can see the waves representing, the jagged waves represent data. If you see a smooth wave, it's the carrier signal. And so we are receiving and sending data. There's also Geotail. There's always one in here I'm not familiar with, which is great. And yes, I was going to talk about this. So this is a perfect chance to mention that we were also talking to the Emirates Mars mission, aka the Hope Mars Orbiter. So right now, we are during the Mars launch window that happens every 26 months, where if you launch a spacecraft from Earth now, you will get, it'll be the shortest possible flight to Mars, about 7 months or so, 7 to 9 months. And so the first mission to launch during this time was the Hope Mars Orbiter from the United Arab Emirates. And this is the first Mars mission coming from the Middle East. There's also a Chinese mission, Tianwen-1, means questions to heaven. And this is a orbiter as well as a rover that is going to be the first Mars rover from China. And also testing out got some science instruments and testing out some mission concepts for a Mars sample return in the 2030s. So that's super exciting. We have multiple possibilities for Mars sample returns.
We have another question.
Cool.
And it is there ever a concern that these assets could be hacked?
So with this, I mean, this is a public website. The actual data that is actually going to the rovers may be a plot in fiction. I don't think it's a serious concern, although also when I mentioned all of the people doing contingencies, I am sure there's a contingency that they do. I don't have information, but it would surprise me.
Well, let me add one other factoid, is that in terms of public reports, I've only seen one instance where there was a satellite that had been successfully hacked and taken over, which was a telecom satellite that operated over the Pacific. But there's a lot of emphasis and concern about encryption, and some things are communicated with by directional signal. So you have to know where it is to get to it and give it instructions. So there are a number of issues involved there. It's a lot more complicated.
That's a good point. And also, I mean, for this, you would need to get into a radar, like a large radio antenna installation, probably. But it is, I mean, they're definitely looking at security, and there's been some interesting features from NASA about working from home and what they're doing. But actual spacecraft control is, believe, mostly still done from the control rooms. But you could see some of that and see some of the distancing measures done during the launch of Perseverance. There's also So there was not hacking, but there was a mission. It was, I believe, the ICE Explorer or ICE-3 that basically had, the mission had ended, and NASA was fine with it, whomever wanted to communicate with it. And there are actually some ham radio operators, I believe, who I think got some time on the Deep Space Network and attempted to command and spin up this this space probe and give it a new mission, which didn't quite work, but it was still super cool. Good questions. Yeah. So I mentioned a little bit about one of the interesting things about NASA missions is all of the data is public domain. So it's, with some of it, there's some that immediately put raw images on the internet as soon as they're downlinked. So I believe the Mars exploration rovers, Spirit and Opportunity, were the first to do this. Curiosity does, Cassini does. Not all mission, I think InSight does as well. Not all mission teams do this. Generally, it's in a compressed format, and then at some point, 6 months to or a year, it's going to be released to the Planetary Data System, so large and complex system where the calibrated, like full resolution official images will be there, and they are available to everyone. The reason that they're compressed when they initially come down is also there are project scientists specifically working with each of these missions to make sure they kind of get their turn with the data before it goes to everyone. And then there are also some missions that only publicly release later when they do the PDS uploads. But there's a ton of amazing things you can find. So the Parker Solar Probe, this is one that is doing later data releases. I believe the next one that is coming up is in November. I'll check that out. This is Mars Curiosity rover, or yes, you can also see the raw images. So these over here, it looks like there was some drilling and some imaging of that. And that was yesterday on the planet Mars. So it's really amazing and awing to just have this available to everyone with an internet connection. Mars Exploration Rover, its Opportunity SAD hours. So Opportunity, the end of mission was declared February 13th of 2019 after a long time of trying to get back in touch with her. I believe the last actual communication was in June 2018, so they certainly tried for a long time. But all of the images, again, are available publicly on the internet, and there's so much data that comes back from these missions. With any of these, I mentioned, feeling sad about end of mission. People are going to be studying this for years, potentially for decades. There have been people have gone back and found new information in data from Voyager. I believe there's an image processor who found some images of moons that had previously not been noticed. There's just so much. I've also heard of papers at conferences being presented from Apollo data. There's just so much we can learn from what we have. I mentioned JunoCam. So this is, and I have all the websites at the end, but you can vote for what sorts of targets JunoCam should image on the next Peri-Jove. You can browse image processing. You can upload your own stuff. You can look at the raw data. So that's really exciting. And again, it's exciting just to have that be, have the public be included in the imaging. DSN now. Cassini, it's also Cassini SAT hours. The Cassini orbiter at SAT hours had 3 times extended missions, active basically for half of Saturn's year. And the overall mission, including crews from Earth, was about 20 years. Amazingly successful mission. Just a few, these are random raw images. We've got some of Titan, some of the rings. They're just really, really stunning. And there's a lot of them. So again, people are going to be learning, scientists are going to be learning from these for years. But you can look up, you can search by moons. There's just really striking things available. And then Perseverance. So right now, it's been 2 days. So when she launched, there was an issue. I mentioned the Deep Space Network, and these antennae are very sensitive because they are potentially getting data from spacecraft that are amazingly far away. Like when you talk about Voyager 1, that is by one definition outside of the solar system, at least outside of the sun's magnetic field. So they're so sensitive that having a spacecraft transmitting very close to Earth can be a problem. So one of the issues right after launch, which they figured would happen, was just the signal being loud and sort of overwhelming effectively on the Deep Space Network. Also, it took them a little bit to get spacecraft telemetry back, the data to make sure that the spacecraft was functioning properly after separation from the rocket. They also, she put herself into safe mode after launch, going through the Earth's shadow. Basically, there were some temperature readings that were like cooling from the radioisotope thermal generator, and like making sure things didn't overheat and didn't get too cold. And with going through the Earth's shadow, it basically was a little bit outside of the temperature parameters that the spacecraft expected. So it put itself into safe mode. And then it's sort of a neutral mode that then the project team were able to communicate with the spacecraft and bring her back into normal operations. So that's something you'll periodically hear about as part of the programming. If there's some parameter that's outside of what's expected, the spacecraft will go into safe mode. And yeah, so let me go back to my slideshow. Worked. Amazing. Okay, cool. So, cool. So I also mentioned, when you hear about robotic spaceflight, it might sound like these are autonomous vehicles, and they're getting a little bit more like that each way. So with the Curiosity rover, the Curiosity did partially have an autonomous driving mode. There are some cameras where some navigation cameras behind and in front on the front and back of the rover, some hazard avoidance cameras, where either the rover team could look at the terrain ahead and plan and give commands for the drive, or potentially have kind of an autonomous hazard avoidance mode if it seemed like it was a pretty basic good terrain. With Perseverance, there's actually the opportunity, Perseverance has the technology to do something similar, but with the landing site, and to potentially avoid hazards in the landing site. So that's really exciting. We've been able to have more and more precise landing for our Mars rovers. So someplace, I'm starting with early landers like Viking, they basically went to very flat, relatively boring spots because the precision of what's called the landing ellipse was such that they figured anywhere in this fairly large area would be safe for this lander to land. With Pathfinder, the landing ellipse got smaller. WISPR and Opportunity even smaller. And with Curiosity, it's actually a small enough landing ellipse so that they could land within a crater. And that is something that would not have been possible in the Viking days. But with Perseverance, there's going to be it will be able to avoid hazards as it lands. It's also instrumented with more cameras. So there's going to be a view of the sky crane. There's going to be a view of, so this is literally lowered to the surface of Mars from a crane that is hovering via rockets. It's quite a thing. It's happened once before. It just does not get old. We'll also be able to see the parachute. So excited for more cameras for entry, descent, and landing. But so yeah, let's chat. I've kind of hinted at amateur image processing. The photo up on the screen is processed by me. This is a bit from the Opportunity rover. With Opportunity, with her panoramic camera, she had multiple filters. So this was something where she'd take an image through a red, green, and blue, or basically the closest to those, through filters that were sensitive to those wavelengths, and then you could combine that in an image processing software. So that's what I did here. It's not completely calibrated data, so it's a little darker. The colors are a little weird. That should not be considered true color. With Curiosity's cameras are actually a lot closer to your cell phone camera. So while there's not a guarantee it's what human eyes would see on the surface of Mars, it is what your cell phone would see. And you also sometimes see images released that are described as white balanced. So that is closer to what human eyes would see. But this is just a fun little thing I did from publicly available data. When I mentioned that people are doing really cool things with old data, this is some reprocessing of Voyager 1. Since the time of Voyager, there have been more sophisticated instruments on missions like the Galileo mission to Jupiter, Cassini did a flyby, and then, of course, Juno, and also more sophisticated image processing software. So this is something with particularly subtler colors. The photos are still amazing, but this is maybe a little bit subtler of a view of Jupiter than would have been seen from the original Voyager 1 data. This was the images were taken around in 1979. This was processed by Bjorn Johnson, an amateur image processor. So very beautiful work. And this is fairly accurate to what it would actually look like. This is the true color image. Kind of going in a different direction. This is done by Damia Buik. And she's processed this image from Curiosity in more of an artistic way. So this is a black and white image that she has used other color photos from Mars and from the rover and basically put color into this black and white image and kind of not in a perfectly scientifically accurate way, but deliberately in an aesthetically pleasing way. So she's done another, all the people whose work I've highlighted here have done a lot of interesting amateur images.
So Elizabeth, can you give people sort of a basic description of how that process works? I mean, it doesn't need to be too technical, but I don't think everybody's familiar with that.
Yeah, that's cool. Okay, so if you have a photo editing software, there's actually the option to, actually, let me back up. Cool. So the images on my screen and yours are in RGB format, or red, green, blue. That is the way that the colors of light combine. Sometimes you may also hear CMYK, cyan, magenta, yellow, black. That is subtractive color mixing and the way that ink mixes. So that is for print. But with red, green, blue, it means that all the colors you see are those kinds of light combined. So for something like the first photo I showed, that would be researching the raw images. So I searched in the raw images from Opportunity's website, and they list what filters, there's data and documentation available on what the file names mean. So I go like left, panoramic camera, the red filter, the green filter, and the blue filter. And then I go into my photo editing software of any flavor. There's different commercial ones available. And it's been a while, there's a way you can actually pick out the red, green, and blue channels in an image. And in each of them, I put them in, I put the red filter image into the red channel, and then the software combines it. I hope that makes sense. That's not super clear. I believe that's the case with what Bjorn Johnson did here. There may be some other processing, because I believe with Voyager, it's not red, green, blue, which, side note, the color sensing cones in your eyes are also sensitive to red, green, and blue light. So you can find them in your eyes. It's more like orange, green, and violet, maybe. So the wavelengths are a little bit different, but you can combine them. I think it's kind of searching through the data. This is also a mosaic. So that's the other thing I should mention, that another thing in image processing is to basically put together a bunch of separate frames into a single image. So with Curiosity's self-portraits, that is not the same, even though it sounds like it's holding out your phone and taking a selfie. it's not the same. It's a bunch of like one photo. I've actually done this, cutting them out and having people assemble them on paper. So one photo might be like one side of the mast and then another, and then a bit of the rover deck. And so humans are actually going into software and stitching together the different images. And I think there's more and more software available to do that.
So the other thing I'd point out here, Elizabeth, is what you're talking about with the fact that they've used mosaics and sort of used the software to merge things. This is very much the same technology we may talk about in fake news in some of our other lectures, but it's done for good, which is okay. You know, it allows them to sharpen focus to a certain extent through machine tools. It allows them to take multiple photos and give you more of a perspective overall look like the full planet. And that's something I wanted to be sure that we covered, because I don't think most of our audience would be aware of it. And I really appreciate you doing that.
Yeah, no problem. And thanks for bringing that up. So I should also say, I didn't mention it, but it is very relevant. My background is graphic design. So that's what I was doing before I was a maker professional. Design is still very important to me. So that's why I'd be like, oh, image processing, like kind of a way into this. And it's a very good point. Like, yes, these techniques can be used for dubious ends. So the important thing is to be honest with this. So that's why if you look at, astronomical images, if you look at planetary images, often they'll say, this is a true color or this is a false color or enhanced color. So with the goal of enhanced color, sometimes you'll see like very bright, almost like rainbow colored images from planets. There's some striking ones done with Mercury, for example, but the goal is actually using the color to kind of give more contrast and point out the difference in terrain. It could also correspond to different minerals. When you look at Hubble Space Telescope images, for example, you see like this very beautiful, like picturesque thing. Those colors correspond to different gases and sometimes to what's visible in different sorts of light, but it is a human who is making those decisions. And there's very much scientific information, there's scientific decisions, there are also aesthetic decisions. So again, if they're doing it right, they'll say, oh, this is a false color, or this is a true color, or this corresponds, or contrast has been enhanced, or it's made into a mosaic, which I believe Voyager one was. So yeah, this is definitely, people should be clear about what they're doing. And the image processors, I know, will all, talk about what it goes into it. Same to the official images for Curiosity. You'll always see if they tweet something, someone will ask, well, where's the robot arm? The robot arm isn't there because those images have been taken out. So thank you. That's a great point. All right. And then with this, so I don't know exactly what she did, but this is basically colorizing or painting. If I were to do this, I'd probably start with a transparent overlay of the color I wanted on top of the black and white image. And I might even, there are ways that you can sort of, maybe I put the black and white on top of the color and then use a mask or do something to let some of the color here show through. So again, sort of photo editing techniques. So for further stuff, these are a number of the different websites that I showed. Again, highly recommend checking these out, and I'll leave this up so people can take a look at it. This is all public stuff. There's even more, and I'm open for more questions. I can't hear you.
It's better if I press the button because I have a manual. But I know we didn't rehearse this, but I do have a question for you to see if you have some knowledge.
Okay.
You basically talked about the NASA strategy for doing things and sending robots into space. In particular, one of the things that I've looked at a little bit is the different strategies of other peer competitors. The Indians, for example, have a really different strategy about that. And I'm curious if you have any knowledge about that you'd like to share.
Yeah, so My understanding of the ISRO, the Indian Space Agency, so they have done a Mars orbiter mission. Oh, I didn't mention there's like 6 orbiters at Mars right now. There's 3 from NASA, 2 from the European Space Agency, and 1 from ISRO. And with them, their goal was actually developing everything in India. And they had a really an interesting and different way of doing the orbit. So it was kind of, took longer, and it was a slower way to get to Mars, but it actually took less fuel. So it's sort of like more gradually making the orbit bigger. And then we just ran screaming into the end of my knowledge of orbital dynamics. But it was a different strategy than like a Perseverance.
Well, one of the other important things I saw with that strategy is they tend to do missions that have single purposes and try to launch a lot smaller satellites and robots. So that's an important consideration. There's some countries we don't have as much information on, and maybe we should talk another time about doing something broader on international space, because I've followed the Japanese and especially the small launch companies like the outfit out of New Zealand that looks like they're almost shooting it out of a back of a truck, so to speak, to get to low Earth orbit. So I've got a couple of questions for you from the folks. One was from Christopher.
Actually, I was going to say one thing I really liked you mentioning about the complexity of missions. I think that's a very good point. I wanted to put something on there. I think that's a very good description of ISRO's strategy versus some of NASA's. One thing to know about NASA missions is there's actually 3 different classes of mission, all of which are still fairly complex. But the flagship mission is something like Cassini, like Curiosity, like Perseverance. Those, as planned at least at one point, are kind of like a once a decade thing. Those are very, very complex with lots of instruments and the highest price tag, although still is a very, very small part of NASA's budget. Then there's also the New Frontiers class mission. So these are different science teams will propose mission concepts that are then competed. And the goal is maybe there'll be like a couple of those a decade. That's New Horizons that went by Pluto and the Kuiper Belt Object Arrokoth, and then further out. Also Dawn. Actually, sorry, spoke wrong. So there's also the smallest mission are the Discovery class missions. Juno is considered one of them. Dawn is one of them. And I forget which one OSIRIS-REx is, but there's one of 2. So there's kind of levels of complexity. But thank you. Yeah. So which photo
Let's try to cover some questions before they move off the scroller for me.
Yes, thank you.
Christopher asks, which photo processing software would you recommend?
With my solar system ambassador hat on, which I do have for this event, even though I'm not wearing my badge, I cannot officially endorse a product. However, that is a product that is available out there. So that would be one option that you have to do image processing. Yeah, something like that. That's a pixel editor is what you want.
So could you talk to the kinds of pixel editors that you are aware of that are out there without giving them an endorsement?
Absolutely. So I don't know if Corel has one. There's Photoshop. There are some free ones. I believe there's one called the GIMP. There's something else I came across. But basically, so you don't want vector. You don't want something like Inkscape or Illustrator. I wonder if you can even do something in Paint. That sort of pixel image editor.
Okay. So we've got another one, and this is a little off topic. Somebody wants to know about your makerspace.
Yeah, so we have 3D printers. We have computer numerically controlled routers, both desktop and large. We have wood shop tools, laser cutter, a vinyl cutter. Yeah.
Okay.
And I'm actually, there's one that I run professionally. I'm also a member of another one.
Okay, and then Jay is interested in, can you talk about the automated mining mission options to the asteroids?
It's a great question. I don't know a whole lot. I know there was at one point a kind of a plan to capture an asteroid and like do some missions to it. Yeah, I know people are.
I think there's still talk about that, but I'm not familiar with any of the details either. But that's something we can look up for our next presentation.
Yeah. Great idea. I love it.
So Joel makes a side comment about metadata handling being important for robotics in space. And I thought that's worth sharing. Let's see here.
Great point. And let's not even get started on metric versus English units, which is why, I believe that's why the Mars, it was a Mars orbiter.
Yeah, somebody put it the wrong data profile for metric versus English units, I think. Thought I heard something about that. I'd have to go look to verify that we're accurate there.
Yeah, yes. There were 2 failures in the 90s. After that, they went back and were very rigorous about testing. But those happened before the era of like Spirit and Opportunity.
Yeah. Anybody else have questions? I'm watching here carefully. We also have one from Jay about commercialization of space. Do you want to talk about that a little bit?
It's a thing. So I think sort of with this lens, with these robotic missions, they are explicitly for science. And part of that also means that, especially with NASA, but to some degree, European Space Agency and Japanese Space Agency, the data is also publicly available. So that is something, the sorts of technologies that are being used and demonstrated, I think there's definitely interest in demonstrating technologies. For example, in Perseverance, there's something called MOXIE that is going to be attempting in situ oxygen extraction. So that's definitely something that could be interested for human exploration. And you know, some of these technologies might have commercial applications, might be used by commercial companies. But I do think that this sort of like publicly available data for science is also very, very valuable.
So let me tag on to that a couple of things that we're aware of, because the other research we've done, you know, when you talk about commercialization of space, there are basically 3 fundamental areas. One is where you're trying to do some kinds of material management or fabrication in space. So there's some talk about using robots to do that. Obviously, the difficulty there is unless you've got a small lift weight to go up, you know, the cost to orbit is the real underlying issue with the ability to do that. Another one that's looked at, and there are a lot of experiments been done on the International Space Station, are things for pharmaceuticals, things that could happen in low gravity that wouldn't be able to be done within the gravity well. But the big thing that I've seen in terms of the near future is, as they reduce the cost to go to LEO, is basically space tourism. And, you know, you hear some of that on the news with SpaceX and Elon Musk and you know, all the other competing commercial companies. So that's part of where it's going. But, you know, again, we're not going to have a tremendous number of launches into space until there's a commercial reason to do it. And, you know, we've got to the point where NASA is not getting the level of funding that it did in the past. And it's because it's a matter of commitment and you're feeling politically of what you can do. So until it becomes commercially viable, right now, I don't think we're going to see a major change in NASA or in the European Space Agency or any of these people's launch rates. Right now, the people who are investing in space are the people who want to have the capability. Iran, Japan. You know, the other thing that's interesting is there's like 127 countries that have their own space agency. And most people don't think about the UAE that just launched their own mission, you know, because they're using other people's facilities under contract for the most part. And some of them are building them from scratch, like the Iranians.
Yeah, and with the UAE mission, I believe they're also working with people in South Korea. So yeah, thank you for bringing in the international perspective on that. In terms of other, you know, robotic technologies, bringing together 2 of my interests, NASA has sponsored a number of competitions for habitat architecture on Mars, and I've met some of the people who won those. There's some idea of autonomously using robots, basically rovers with robot arms that are 3D printing, which is like combining multiple things I really love. to make a habitat, to send some sort of a robotic landers and printers to make these habitats that an astronauts would come and inhabit later. So I think that is super interesting.
Yep, and that's another thing with the small robots. If you can build an army of ant-like robots that can do construction, that's a big plus, or things that can utilize on-site materials. So let's see. I guess I have to call him Crazy Yog because that's the way he refers to himself or herself. Can you talk about the mission to the asteroid Psyche and how? I hope I pronounced that right. And the one thing they were doing about a partial core of the planet.
Yeah, that's super exciting. And thank you for reminding me of that, because I actually intended to talk about a couple of future missions. So I mentioned the Discovery program where different missions are competed. And there were 2 winners actually in the most recent down select, they call it, to go forward and go into development. And so that was Dragonfly, which is going to be a small helicopter on the surface of Titan, Saturn's moon, which is a very thick nitrogen atmosphere. So unlike helicopters on Mars, that might actually be a little bit easier with the atmosphere, although also it's so very far away. But that is going to be a really cool mission. The other mission that is also going to be very cool is Psyche. So that is going to a metal asteroid. And the theory is, in fact, that it was the core of a planet. When planets form, I mentioned a tiny bit about the formation of Jupiter. Basically, the planetary disk is coalescing and stuff clumps together. This is a very, very broad summary. At a certain point, you get enough material that it goes into a ball and it starts to differentiate, which means it gets very, very hot. And the heaviest stuff goes towards the middle. So this is how the Earth has an iron core. With what they think happened with asteroid Psyche is there was some sort of a differentiated body or protoplanet that something else slammed into, and what is left is this metal asteroid. So that's going to be really exciting to learn about that. I don't know when that's due for launch. International missions mostly. So the ones I mentioned all the ones I mentioned here are scientific, but yes, there are so many satellites. I'm barely scratching the surface of planetary science missions. There's so many more Earth observing missions, and then there's so many more telecommunication satellites that are also international.
People don't realize how many zillions of satellites and parts of former satellites are in orbit. And that's something we actually had in one of our presentations last year, a little graphic that showed the density by orbital space. So maybe we'll do that one again now that we're doing video casts. Now we've also got a question about sample return with projects.
Yeah, so both China is looking at doing sample return with Tianwen, and the US is looking at doing sample return with Perseverance. That basically, Perseverance is the sample caching rover. There's 2 other parts of that mission. I don't know if that mission architecture has been done yet. So that is, the caches will stay good for about 10 years. It's every 26 months you get the launch window. And so there's basically an idea to have 2 more missions. One is something that would collect that, and then something that, and a launcher from the surface that would also be met by another probe that is coming from Earth and going back to Earth. So the 3rd probe would stay in orbit.
Yeah, so if I understand it right, basically you've got the first mission that collects, the second mission which goes into the collection site, tosses it into LEO around Mars, and then the 3rd mission is a retrieval mission where you have the robot arm reach out and grab it and bring it home.
Yes. So that is Martian. With asteroid sample return, so you're hitting all of the exciting things I did not get to, and I love it. There actually, I believe there are definitely 2 different asteroid missions, and I believe they are both looking at doing sample return right now from different asteroids. So there is Japanese Space Agency's Hayabusa 2 at asteroid Ryugu, and there is NASA's OSIRIS-REx at asteroid Bennu. I believe both of them with slightly different technology are taking samples, and they're going to be put in, I believe, like they put them into containers and then like go back into Earth orbit and drop them. Look that up. It's quite something. It has been done before with Hayabusa 1, which was an amazingly, just like stunningly dramatic mission in how many things went wrong. And ultimately, they were actually able to safely return a sample. There was some collaboration of JPL and JAXA, which is the Japanese agency. So super exciting. Apparently, there's like 3 Japanese feature films, which I need to see.
So Jay has another question about any construction plans for robotic building future space stations or moon stations, turning machines, and I can jump on that one because the answer is there's a lot of stuff on the drawing board, but nothing's live, because that was a discussion topic at RavenCon last year where we had a bunch of guys from the Langley NASA post that were talking about those kind of things. The other thing that he had as a question is there real-time monitoring 3D map of space debris? Yes, there is, and some of it's public, not all of it, because the near-Earth orbit stuff is for the most part public, and you have both sources from things like the UN, which is in charge of orbital locations and public distribution so people don't launch satellites in one another's way. And then some information is available through DoD because Space Command, in its old form and its new form, does real live tracking of all those pieces so that they don't have a real catastrophe with the next thing they send up. So do you want to add to that, Elizabeth?
What he said. Yep. Thank you. No, this is great. This is great.
Okay. Now here's a question about the Mars helicopter. Is it one flight or return to the rover or land for reuse?
I believe it's going to, it'll last for about 2 weeks. I'm not sure. It looked like it had solar panels. I'm not sure if it has how precisely it recharges. But it's gonna do a bit. It's not expected to last the entire time of the mission. With Dragonfly, which is the Titan helicopter, it actually looks a lot like a Curiosity body. It sounds like it would be like very small, but maybe like a prehistoric Dragonfly that were really, really huge. Anyway, it's almost like a Curiosity body with its own radioisotope thermal generator and the helicopter rotors. So that is also, it's gonna fly to a destination, do some science, and then fly to another one.
And I do want to thank Joel for his post because he just listed one of the sites that shows real-time tracking. And he's been very active sharing some of the experience and expertise that he has. Any more questions, folks? Because we're ahead of schedule. So we can keep going, but we don't want to waste your time. So if we run out of questions, we'll stop. In absence of questions, I'll do a little important fill. We are regular attendees now at Escape Philosophy,
I was going to say, I have
the science fiction convention. If you want to find us and what we're doing, watch our Facebook page because we'll announce when we're going to have seminars. And we are going to make the attempt. We've been doing some prototyping to run games actually at DragonCon, although there won't be as many as there have been in the past. And Escape Philosophy is something we're working with. So we are likely to do at least one game there, but we will also be involved in panels. And just as a advance hint, there's going to be a panel on space law, because I've been promoting that and may or may not be on the panel because I'm not a great expert, but I'm an instigator. So there's a question for you, Elizabeth. Do you play Kerbal Space?
I have seen it. I have not played it. My partner Ryan, who I presented with last night, has.
Okay.
But I know that there are many, many people who work in this professionally who also enjoy it.
And considering our audience,
from Joel saying Earth monitoring satellite specialized, and I'm really tempted. Like I've done the planetary science presentations. I'm really tempted to do an Earth observing one. This is also near and dear to my heart. My maternal grandfather worked on satellites. He was a machinist for RCA Astro Electronics. when they worked on Tyros, which I believe was the first weather satellite. They did defense, they did communication, they had weather satellites. Astro Electronics also worked on some of the Ranger missions and on Viking.
Fantastic.
And the camera on some of the lunar rovers that had astronauts in them.
So I'm going to do my other plug. You could come and work with us like Elizabeth has, because it's long hours with no pay, and you get to hang out with cool people. So if you're interested, you can always send us a message on Facebook, because we are looking to expand the topics that we deal with so that we're better for our games and better in terms of understanding how the world works, because this has always been for us as our avocation, not our vocation, learning about how the world works. And we're thrilled to death that Elizabeth and a few other folks have joined us this year, because they have added a wonderful perspective and a lot of experience that we really want and need. I'm checking one more time for questions.
Thank you, everyone.
Have you played the board game High Frontier? It's brand new. I haven't. I don't know if Elizabeth has. I do also have.
I have not.
Conquest. Yeah, they're both really cool.
What's up?
I said they're both really cool.
High Frontier, there was a scientist who was involved with the Rosetta mission who also did some board game design. So I don't know if it's that one, but I know there's some that are like supposed to be very realistic in terms of space exploration. I've not played any of those.
There's also a lot of other games that are space-like, but when you're looking for stuff that has more of a sense of where things could go or what the history was, some of them are better than others. I just got a copy of one that goes back a number of years called Liftoff, about the early space race, which was an old task force game. So there's a lot of stuff there, but that's a different lecture and a different discussion. I don't see any other questions. So I want to thank everybody again, especially Elizabeth, because she did a great job. And please join us for our other broadcasts. We're going to start at 10 o'clock with our Global Hotspots lecture, where we talk about the normal things that are going on in the world and the abnormal things that are going on in the world, and give you our unsolicited opinions because we read the news. So please join us. Also have a safe and happy weekend. So we're going to leave the broadcast. Thank you so much, folks.